My name's Jeffrey. I'm a data scientist at Kickstarter, and I'm going to tell you a little about how I helped to add automation to our community support team and how that project helped us all to be a little more human. As many of you probably know, Kickstarter is a crowdfunding site for raising money for creative projects. There's lots of creators who come to Kickstarter to raise money for their documentaries, food trucks, board games, fidget cubes, and there's lots more backers who come to make pledges to these projects, often in exchange for a promised future reward. So if you give me money so I can record my country album, then I'll send you a copy of it when it's done in a year. That's how it works. So, oops, there's the next button. Okay. There's lots of types of people who use the Kickstarter platform, and there are just as many ways that things can go wrong for them. So when things do go wrong, people can go on our website to the help section, type into a text box with their question, and that'll get sent along as an email to our support team. And like many companies that have products and users, Kickstarter has a dedicated customer support team, which we call the community support team, or the CS team. These are the folks who answer these support emails from the users. We have 9 dedicated in-house CS agents and 7 remote contractors that altogether answer around 1,500 to 2,000 of these support emails every week, otherwise known as tickets. So, you know, not a huge scale, but still a lot for a small team. And I think that these community support employees are the people, they're really the folks who most understand how our product works and who our users really are. And partially because of that, everybody in our company participates in something called a support rotation. And that's when you spend a week learning how to be a community support agent. And you answer a handful of tickets. And it's a great way to learn about the ins and outs of our own platform. And in your support rotation, you can't help but gain like a deeper empathy for the actual humans who use Kickstarter. And it's also a great way to gain stronger empathy for your coworkers who actually work on the community support team full time, which I think has a lot of value. So I signed up for this support rotation the first week it was offered, and I learned quite a lot when I was doing it. First, I learned that answering support tickets is very hard, and as much as I would like to think otherwise, I realized I was definitely not an expert on how Kickstarter's own products work. Secondly, and it sounds kind of funny to say, but I learned that our users are real people. As data folks, our jobs are to understand our users through the data that they generate. But really, the data points are only shadows of the humans that create them. And in communicating directly to these users, these people, engaging them in conversation through my support rotation, it served as an important reminder to me that the people using our products are much more deep and nuanced than any tracking data could ever hope to capture. So the third thing I learned on my support rotation was how the support ticketing system works behind the curtain. So when a user writes a support ticket into a text box on our website, it gets sent to a third-party community support platform called Zendesk, which probably a lot of people are familiar with. It's pretty powerful. Incoming tickets are automatically linked to metadata about the user who wrote the ticket, such as if they're a backer or a creator, how old their account is, stuff like that. That gets all sent in. And then these tickets pile up in the queues in Zendesk, and that's where our community support agents log in and they pick them off and write responses to them. Pretty standard stuff. But the agents don't usually write responses from scratch, and this is something that probably a lot of people already know about, but I didn't. And instead, for commonly asked questions from users, our community support agents just apply a simple tag to the ticket, and that tag generates a pre-written templated response known as a macro. So in this case, like the ticket is about if Kickstarter has phone support, and they would just apply a tag called phone support, and it would attach this like pre-written response. Just approximate content. Some of these responses are customizable, others are self-contained. And some of them serve to get the conversation going, and others serve to resolve issues with finality. So these Zendesk tags can trigger other things too, like rerouting support tickets to different agents, or even sending off responses automatically rather than just populating the response field. And the community support team is in charge of how all this stuff is configured within Zendesk. And they're very efficient at it. They can like churn through these things really fast. Okay, yeah, all this data that lives in Zendesk, the tickets, the tags, the responses, it all gets copied to the Kickstarter database regularly using a service called Fivetran that we use to copy that data. Okay, and finally on my support rotation, I learned firsthand just about the pain points and the bottlenecks of the community support workflow. So first of all, like I mentioned, the team is pretty small, and the ticket volume is high for that amount of people. And I learned that though a lot of the tickets that come in do require a lot of high-touch, bespoke responses, many of the other tickets that come in can be solved with a straightforward, factual, pre-written macro in just a matter of seconds. And so, but those seconds add up. And so the idea arose that if we could perhaps automate some of these easier responses, it could help the community support folks to free up some valuable energy that they could otherwise be spending on the harder tickets, and as well as other things that that team wants to prioritize, such as like rewriting our frequently asked question pages, or like configuring more things in Zendesk, and I don't know, all sorts of stuff. Training new employees. So, okay, so I wanted to try to build a classifier that could automatically pick a macro for a ticket based on the content of the ticket's text, just a text classification. And I felt like I was actually in a lucky position to be able to take this project on with a lot of autonomy. So for a little bit about Kickstarter, for a fairly well-known brand, which I think Kickstarter is, we're actually pretty small. Our data team consists of just 6 people. I'm the one data scientist there, and it's largely been my job to come up with data products like these and to figure out how to collaborate with people to get them built. And I did have space on my roadmap for an internal tools project like this, and so I decided to go all in on this effort and try to help out our colleagues on the community support team. Okay. So now, getting robots to do customer support is not a new thing. We've already talked about chatbots this very day. We've all experienced online help and chat room support. Sometimes it works better than others. Sometimes it feels like it's coming from the wrong side of the uncanny valley. And at Kickstarter, it was always important for me and for the community support team that we proceed with care and discretion when heading down this road towards automation. We wanted to make sure that whatever we built would be done not to replace the need for human help, but rather to relieve the humans on the community support team of their most repetitive, sort of unhuman tasks, so they could focus on the more human tasks. Common story. And from the user perspective, we wanted to make sure that if we ever ended up actually sending out automated responses, that we would own that fact and own the fact that the reply was automated and message it as such. It's like, hey, this is a robot, and we think that you're interested in this information. If it's not, if we're wrong, then that's cool. So we also decided that this automation, if we built it, would only be designed to work on first touch tickets, meaning that if a user ever replied back to a robot, it would always get sent to a human. So we wanted to set our guardrails pretty modestly and not try to build something that was going to get us a bad reputation or something. So with all this in mind, I set out to try to build my little classifier. And as a machine learning classification project, it's like a fun problem. And for this particular context, it was particularly fun because the training data was built in. The text of the tickets forms my features, and the Zendesk macro tags that were used to respond to those tickets would form the labels. And so I could just tokenize this ticket text, make some simple bags of words for each ticket, run those through some kind of a classifier, and get an array of probabilities or scores corresponding to each possible output label, and then perhaps figure out how, if any of those probabilities are high enough, we could take some action, like automatically sending a response or something. So I started out as simple as possible. I used the tools that I knew how to use, which is R and GLMNet, to just build a simple multi-class logistic regression classifier on a sample of a few thousand tickets. And sort of naively, at my first attempt was I tried to use all the tokens for my features. I tried to use all the tokens and 2 grams that appeared in all my tickets, which was in tens of thousands of features. And for my labels, I just wanted to use all the macro tags that were ever used to respond to those tickets in my sample, of which there are over 100 different ones. So this model did not converge. It definitely just overflowed in R, or whatever happens when R breaks. And so I did the next thing, which is cleaned up my feature set using standard stuff like stimming, removing stop words, removing sparse terms from my bags of words. And I worked with the CS team to pare down my training labels by just figuring out what are the macro tags that we might actually really want to automate in the end. And also by grouping together different sets of multiple related macro tags into parent labels so we could perhaps just like group into one action. And this got the number of labels down to like 10 or 8. And this model did converge and had decent accuracy, seemed to work with some sense. And so I put it into a Shiny app so I could show it off and try to get some buy-in. And this is sort of a simplified version of what that looked like. And in this prototype, it wasn't perfect. Some of the labels were easier to sort of hit than others, like when sort of showing it to people. And it definitely didn't cover the a very huge portion of the real-life continuum of support tickets. But it was enough to get people interested in the project. And so I was able to get together in a room with some platform and engineering folks, and as well as some community support folks and my manager on the data team, and we brainstormed different products that this prototype could lead to. And so my first naive idea was that maybe we could just build something a lot like this prototype, where you get real-time pop-up help suggestions as you're typing on the website. So as you're typing your support question, we would classify your text in real time and surface relevant help articles or FAQ links to hopefully answer your question without you having to submit a support ticket in the first place. And that's lots of companies have this kind of thing, and you can definitely buy this as a service. Zendesk, I don't know if Zendesk does real time, but they sell this kind of thing. But for us to build this would require a lot of product design and front-end development. And we didn't have the resources for that for this project. So it's kind of like a low-key project. So instead, for our MVP, we just decided to build a classifier that would bypass any user-facing interface. And instead, after classifying the text of a ticket, we would just use Zendesk's API to reach back into Zendesk and apply a tag directly on the ticket that we classified based on whatever the predicted classification was. So then those automated tags, once they are applied in Zendesk, could then be configured to trigger different actions, such as auto-responding to tickets, or sorting tickets by priority, or routing tickets to different CS agents or groups. And so, like I said, this MVP would not have any front-end components, so we could kind of fly under the radar in building it. And best of all, it would keep most of the action within the Zendesk ecosystem. And that was important to me because the community support team, who sort of owns that Zendesk ecosystem, would be able to have the ultimate say as to what gets automated and what doesn't. And I think that was important. So we decided to build the thing, and we named it Sassy. That's a portmanteau of support classifier. And you can ask me later about our classy, flashy, and trashy, our other classifiers. Classy is for auto-approving projects, flashy is for predicting success, and trashy is a spam classifier. Okay, so next we had to just figure out where we were going to build this thing in our stack. So my first sort of naive thought was, well, why don't we just use the Shiny app that I already built? But I looked online to see if Shiny was recommended for use at production scale, and I found mixed reviews, and also none of the engineering people that we work with know anything about Shiny, so we decided that was maybe not the right way to go. I don't know if Shiny is used for production, but maybe it is, maybe it isn't. I don't know. But we didn't go for that. So the next thought was maybe we could just bolt Sassy onto our already monolithic Kickstarter Rails app. We already have one text classifier that lives in the Rails app. It's a logistic regression classifier. Pretty simple. So we could reuse a lot of that code. But being a logistic regression, going that route, we would probably be limiting ourselves to using logistic regression for what the model inside Sassy would be. And I was a bit wary of that because I wanted to try out other models that might be able to have nonlinear stuff. So also, the engineering team at this point was making a big push to get away from this monolithic architecture, more towards microservices. So adding stuff to the monolith was not something they were super keen on doing either. So the better option was to just let Sassy be its own microservice. And it was a great candidate for being a microservice. It was brand new, so they wouldn't have to refactor existing code. I mean, maybe that's a good or bad, I don't know. But to me, it was good. And it's a pretty autonomous, so it doesn't need to really interact with any other resources outside of itself to be able to work. So we had a winner, and Sassy was greenlit, and we all aligned our roadmaps. There she is. So the platform folks would help to build the services plumbing. Other engineering folks would help to hook the Kickstarter Rails app up to this service to call into it, and then apply the responses from the service into the Zendesk API. The data person, me, would train the model and figure out how to insert it in the code base of that service. And most importantly, the community support team was on board. And they put goals on their timeline to be able to automatically prioritize, reroute, and auto-reply to some tickets by the end of the year. This was like, I guess, a year and a half ago. Yeah, so the Kickstarter engineering team had decided that all of our new microservices would be written in Java. They surveyed a few different languages and decided that was the best one for our needs. And so that's what we decided that we would use to build Sassy. So for me, that meant that I had to figure out how to train a model in R, but then, because that's what I know how to use, and then deploy it in Java. And I also had to learn some Java to begin with, which I was actually excited to do because, I don't know, I'd done C++ in my previous job, and those languages are kind of similar. So that was actually exciting to get to learn something new. But I didn't know anything about how to do machine learning in Java or how to go from there to there. And I think this challenge of figuring out how to productionize your prototypes is something, well, it's something I've run up against several times. Probably other people have too. And I mean, with some classifiers, like logistic regression, the model logic is simple enough that you can encapsulate it just as a list of coefficients. So it's not that hard to just like copy those coefficients from where you train the thing into the thing where you serve the thing, and then you have your model running on production. But more complicated models like tree-based models or neural networks are not so easy to just port by hand. And there are lots of solutions for this, but it's still a problem that requires some thought. But I was in luck because for this specific case of going from R into Java, there is a popular product available that's H2O. So it's an open source machine learning platform a lot of people have probably heard of. It runs on the JVM and exploits a lot of nice things there, does a lot of parallel processing for loading and modeling data fast, can scale. It also has nice interfaces for your favorite machine learning training languages like R, Python, Scala, and it also has a web GUI. Yeah, so we decided to try out H2O. It worked for us because it also has a lot of different types of classification models that it can train, from naive Bayes classifiers to deep learning models. This is the one that we settled on, which was a tree-based model, a gradient boosting machine. And yeah, so that's actually just that's the command for training the thing on with a bunch of hyperparameters that we spent a lot of time trying to figure out how to optimize. So okay, so once you train your H2O model, which could take minutes or hours depending on your machine and your data size and cross-validation size and all that stuff, then you have it sitting there in memory in R. It's just this file called model. And so how do you ship this model out to your Java service in order to deploy it? Well, in H2O, what you can do is you export the model as what's called a POJO. And that's just an acronym that means plain old Java object. And POJO looks something like this. That's the POJO for Sassy. It's just a bunch of auto-generated code. You can't really see because it clips, but it's about 560,000 lines of code. But it includes all of the logic of this tree-based model. You can kind of see there's lots of if-then statements. The thing that's nice about it is it exports all of that logic as a Java class using primitive Java data types and containers. So you can just plug it right into your Java project and it'll work. So it can be massive. This one is pretty massive, but it worked fine. And so once you export your POJO file, then you just bring it over to your Java project and you copy it in, deploy it, and it can just work. And then you have a classifier model that was trained in R, and now it's serving requests on production in Java. So great. But I don't want to make it sound like that was easy for me. I mean, maybe it's easy to do, but for me, it was actually took a long time just to figure out how that whole setup worked. And so, I mean, I spent a lot of time just figuring out all the different parts of this workflow, such as like just learning what the different classifier models do. This is one of my first attempts at like learning, trying out a bunch of different classifier models, and then learning about all their hyperparameters and reading about what the hyperparameters do and seeing how, you know, changing those hyperparameters affect the performance of our particular use case. I spent a lot of time trying to get my text tokenization set up right, and that was kind of like a blunder of poor programming style on my part, but I built a tokenizer in R or wrote a tokenizer in R that would, you know, clean the raw text of a support ticket, tokenize it, and all that stuff. But then I realized that I had to rewrite all that code in Java to be able to tokenize incoming tickets, and so I wound up having like the same code duplicated in 2 different places, which gets a little weird when you're trying to like use sort of third-party stemmers and stuff. So that was kind of like I don't know, it's just something that I painted myself into a corner, and I had to manage that, so that took a little while. Also had to spend a lot of time figuring out that exporting a POJO file is a thing that people do. And actually spent a lot of time on the phone with the patient sales reps at H2O trying to ask them, how do I train a model in Java? And they're like, what do you mean? You export the thing. Eventually, I went to H2O conference and just asked the people, like, how do you use this thing? And then they told me, you use the POJO. So, and then I had to spend a lot of time figuring out how the POJO actually works so I could plug it into the service. And finally, this is a problem where I spent a lot of time figuring out what our success metric should be for this type of a model. And so, you know, the metric that you choose to measure the success of your model, like, I think depends a lot on the expected business use of the model itself. So, for instance, if we're trying to build a classifier that's going to auto-respond to tickets, we probably want to optimize for something like precision. So we maybe are okay with the idea of not auto-responding to many tickets. We just want to make sure that when we do auto-respond, we get it right. But if instead we're doing like pop-up help, like where we maybe offer like 3 or 4 possible help articles as you're typing, then that's that, I forget what someone else called it, but it's like you would only need your answer to be precise within maybe the top 3 or 4 most probable labels. On the other hand, if you're trying to optimize for like reducing the workload of your community support team, then maybe you're trying to optimize, put more weight on like the recall side of things. You want to make sure you classify, take action on as many tickets as possible, and it's okay if you get a few of them wrong. So we kind of didn't really know what our use case was. We kind of wanted to actually serve a lot of those different use cases. So we try to optimize all those things at once by, you know, some of these, what you can do with those, what is it, area under the curve, or F1 measure, or F1 half measure, depending on how you weight things. So anyway, but despite all of those challenges and time-consuming things, after many pull requests, last December we finally did ship this thing called Sassy and saw the first automated tags appearing in Zendesk. That was great. So now if you go to Kickstarter and you submit a support ticket, it'll still get sent over to Zendesk, but it'll also get sent into our little Sassy service, where it'll get tokenized and run through our GBM classifier model, and that will return back to our app a list of labels and probabilities. And then there's some logic and thresholds in that app that will then decide whether it needs to, if any of those probabilities are high enough, then it can reach into Zendesk through its API, find the ticket that it was looking at, and apply the appropriate tag to that ticket. And then actions can be set up to be triggered by that tag within Zendesk. Okay, so this MVP it's viable, but it's still modest. Sassy only applies tags to about 10% of incoming tickets. Of those 10%, the accuracy of which tags it applies it is around 90%. Not great, not bad. That's based on manual quality assessments we've done after we deployed it. Tags that trigger auto responses tend to be a lot more accurate. because we wouldn't use them as auto-responses if they weren't. Then tags would do other things. And there's a lot of things that we could do to improve this thing, like finding maybe a better model that could have more than just like, well, I guess this one represents the, what is this, average time for first response for different Sassy tags. Right now there's only 7 different tags that Sassy could apply. So we could maybe train a different model that could apply like 70 tags instead of 7, but I don't know how to do that yet. So this is what we're working with. But you can see that the response time for things that were tagged by Sassy went down, and the one thing that we did auto responses for, which was people having issues uploading videos and stuff, the response time went way down, which is what we would have hoped. But for all the things that we could do to improve this MVP, we're equipped, and more importantly, the community support team is equipped to iterate on what we already have. And so kind of what I mean by that is that, so as data scientists and engineers, we're all builders, and we build things in service of our users, whether those are external users, such as Kickstarter creators and backers, or in the case of internal tools like this, our users may be our own coworkers. And so part of building things in service of others is in understanding the needs of those users through things like just user research or doing things like support rotations, and just taking an attitude of empathy to everything you do. And in the case of internal tools, I think that part of serving others is in building ourselves out of the equation. So meaning we want to build things in such a way that we empower our colleagues to own and maintain their own tools themselves. So I wanted to do this for Sassy. And I mentioned before that Kickstarter's ecosystem within Zendesk is owned and operated by the community support team. I wanted Sassy to be the same way. So like I kind of alluded to earlier, a major part of Sassy's functionality is the configuration of its training labels. Remember, there's hundreds of macros that the CS team uses, but there's only about 7 or 8 Sassy labels in our little model. So macros are grouped into parent labels for training, and these parent labels are what gets applied as tags in Zendesk. So we knew from the beginning that these labels would not be set in stone, and we need to regularly update and change them as we tested and iterated on this model in the wild, and as the actual content of support tickets change over time, and as the needs of our community support team change over time as well. So I set it up so that the macro groupings live in a config file, and that config file is essentially owned by the community support team. So there it is. And the community support people that I worked with have GitHub access, and they can modify that config file and the groupings of these macro labelings themselves with a pull request. And so then they pretty much own the entire lifecycle of Sassy. So that's Noah's pull request to change the labels, and that's me saying that it looks great. Yeah, so the CS team, they configure, within Zendesk, they configure which actions are triggered by the tags that Sassy produces. They've built dashboards in Looker to monitor Sassy's behavior over time. They perform manual quality assessments of the labels that Sassy does apply to just see how they do in real life. And then, like shown here, they adjust the training label config file in response to these quality assessments, submit those changes on GitHub through a PR. Then the only part where I come in is in approving the PR, and then I execute the training script and the deployment script. And then it's back in their hands. So this lifecycle can continue, and it pretty much is owned by them. Furthermore, like when presenting about this at all hands, like the community support team does the presenting. I'm just in the background to answer technical questions. They've organized talks with other companies to talk about the question of automating support. And again, if I participate, I'm just there to help out if people have like questions about the stack, but it's their show. And I love that. And the most cool thing about this whole process to me is that these community support folks that I worked with have really developed an intuition for the strengths and limits of the machine learning model that we use, and they have a much more better intuition of how it might perform differently on different training label configurations, different types of data. It's pretty cool. So we set out to build a robot to help out humans, and we try to do it with an attitude of empathy, curiosity, and collaboration. And the support rotation that I participated in was an exercise designed in part for us to gain empathy for our users and our colleagues. and the Sassy project sought to bring in automation as a tool so that our community support humans could spend more time being human. And so we built Sassy with the intention for empowering that community support team, both in how the tool functions and how it's maintained and owned by that team. And also, I think working on this project just made me realize that scrappy teams can build cool things. And our team is small, and none of us was really an expert in the field of automation. But we worked with what we had, and we built something cool to better serve our users and our friends, and that feels good. Thank you. Oh, I think there's a question over there.
Hey. So I think early on, you were kind of talking about how you trained the model. So do the tickets, is there only kind of like one tag per ticket? Is that why you could,
Yeah, great
like
question.
as opposed to a ticket being multiple, okay.
Yeah, for the most part, there's mostly one tag per ticket, but there definitely are some overlaps. There are situations where, for whatever reason, maybe it's like because it's a back and forth thread, or maybe because of things I don't understand how Zendesk works, like there would be situations where multiple tags would be applied, or maybe some tags don't correspond to a macro, but they get applied for other reasons. And so they're, I did my best effort to try to like find individually tagged tickets, but there's definitely some fuzziness there. So that's another thing where improving this in the future would be just getting the training data a little bit more like precise. Yeah.
So I'm just curious if you have an opinion on if there are tickets with multiple tags, because a ticket could be partly about passwords and partly about a video, and like, do you know of ways that you can kind of train a model based on more than one kind of label?
Yeah, I mean, I off the top of my head, I imagine you could just like include each example twice, just with different labels, and then perhaps the model could learn that the text signals that correspond to the one label could also correspond to the other label. But I don't know how that would actually perform, but that seems like maybe where I would go with that.
Cool.
Sure.